Hello everyone, and Sir Jules here, and I welcome you all back to my YouTube channel. So for today's video, we'll be continuing with our organic chemistry lecture series. So without further ado, let's start our lesson for the day. So before I proceed, just like any other concepts or any other field of science or other topics, in every topic, there are fundamental concepts that we need to understand before we proceed in discussing about the main topic. So here in organic chemistry, before we start discussing about organic compounds, the carbon molecules, the different functional groups, in order for us to have an understanding of how they behave, how they react, why do they form those kind of molecules, we have to discuss these fundamental topics of for the lesson 1, which is the Lewis structures and electron configuration. Now, for the whole lesson 1, this is a bit lengthy of a topic to discuss in one video, so I'll be segmenting them in different videos. So I'll be discussing about this topic for the next couple of videos that I'll be uploading on my YouTube channel. But for the whole lesson 1 about these Lewis structures and electron configuration, we will be having these learning outcomes. So this is our goal at the end of the whole lesson for the next couple of videos. So our learning outcomes at the end of the lesson, the students will be able to first write the ground state electronic configuration of an atom or ion. Second, draw the Lewis or electronic dot formula of atoms and its ion. So that is our target for the next couple of videos that we'll be discussing about. But for this specific video, let's have first our lesson 1.1. So subatomic particles. Now, it is known that the basic part or component of matter is atom. And atom is distinct. It has its specific characteristics, which is different from among other atoms. Now, atom is a basic unit of an element, but within this atom, they have the so-called the subatomic particles. And I have here a picture to show you what it looks like. So I have here a picture of an atom. So as you can see, we have here the electrons. We have here the nucleus. So the nucleus is at the center of our atom. So it houses the proton and the neutron. So the proton is a positively charged particle, while the neutron, from the name itself, so it's a neutral charge, so it doesn't have charge at all. Now, an atom, despite its size, it's mainly composed of hollow space. Now, outside the nucleus, we have these electron orbits, which houses the electrons, wherein these electrons are negatively charged particles. And based on mass comparison, most of the mass of an atom is housed or contained inside the nucleus because proton and the neutron are heavy particles while electron is just a fraction of their mass. So it's a bit of a lightweight compared to the other two particles, subatomic particles. Now let's have here a further example. Let's have the carbon atom. So as we can see here, this is the number 6. So what does the number 6 tells us about? This is the atomic number. So the atomic number is equivalent to the number of protons and the number of electrons. It's not equivalent to the number of neutrons. It's not always true for every situation. But always remember that the atomic number is equivalent to the number of proton and number of electron. Meanwhile, what we have here underneath, that 12.011, that is the atomic mass of the carbon atom. So this atomic mass is the sum of the mass of the proton and the neutron. As I've mentioned previously, that most of the mass of an atom is housed inside the nucleus, which contain the proton and the neutron, because they are the heaviest part of the atom. They are the heavy ones compared to the electron, which only contains a fraction of their mass. So this tells us that 12 as the atomic mass is the total of the number of proton and neutron within the nucleus of the carbon atom, and 6 are its number of electrons. So we have 1, 2, 3, 4, 5, and 6, right? But I have here a question. Despite the carbon, the atomic mass is equivalent to the sum of the proton and the neutron, but why do we have here a decimal point? So if we have 6 protons and 6 neutrons, it should be 12, right? But why does it represent 12.011? Okay, so here's the explanation, guys. So, as I've mentioned earlier, that 6, the atomic number, is equivalent to the number of protons and number of electrons. But it's not always true for the number of neutrons. Why? Because we have the so-called isotopes. Carbon have a couple more than 5 isotopes. It's really abundant in this planet. And having isotopes is basically having the same carbon. It has the same atomic number. It can't be changed because that gives that specific atom its identity, but its number of neutrons may vary. So let's say there is a carbon that an isotope of carbon. So basically, isotope is just the same element but different number of neutrons. So neutrons could vary. So we have 6 protons, 6 electrons. But if we'll have 7 neutrons, then the atomic mass of that specific isotope of carbon will be 13 and not 12. So that's the reason why. Now, what does this decimal point represent? Since carbon has a couple number of isotopes, let's just say we have here a carbon which has only 5 neutrons or even 4 neutrons, so that's only a 10 atomic mass. So in order to get this number that is shown in our periodic table, basically how IUPAC does it is that they get the average of all these isotopes. That's why we have here a decimal representation of the average of all the isotopes that could more likely represent that carbon as it is. But it's a different isotope. We have different isotopes. So more likely having common ground. So that's why we get the average. So same with statistics and probability, right? We get the mean in order to get that number as a perfect representation of all the samples within a certain selection. So that's how it represents. Okay? So based on our discussion, we have some key things to remember about subatomic particles. Atomic number is equal to the number of protons and electrons. Always remember, atomic number equals to protons and electrons. Now, atomic mass is equal to the sum, which means you add the protons and the neutrons. Now, protons is the positively charged particle, electron is the negatively charged particle, and neutron is just a neutral charge. It doesn't have any charge at all. Okay? So, just a little bit of a trivia before we end this topic about subatomic particles. Did you know that electrons are not free to move from the nucleus, but are confined to regions of space called the principal energy level or shells, and are numbered as 1, 2, 3, and so on? Which means that a specific electron can, let's say we have an electron right here. If you take a look at it, then it's not always going to be there. It could jump from here into here or any other region of space within the orbitals. But before we discuss that, I'll cut short this video as we'll be discussing the topic on the next video. Alright, so I hope you guys learned something about subatomic particles and stay tuned for our next discussion. Thank you.